I'll have to make weird faces in the camera.
Huh? Not only you're allowed to, I expect it. That's what I would do. I mean, you have a golden opportunity here. You can go viral. You could be the next reality show stars. Not sure I'd want to do that.
Yeah, this is the formula for doing this was pretty good.
Huh? I quit. Did you get? I was gonna do this, but I was
Alright guys, I know a few of you guys are still working on this. A lot of you guys are kind of done. I want to make sure that we got this right. So the first thing real quick, let me just catch up to what you guys did. You should have totaled all these up. Let's see. So good. 165, yeah. Sounds familiar.
Is that a 70 or 78?
That's an 8. Alright. So when you do these, always start off nice. Just something like attends Rosemont. So for some reason, I want to make sure everybody reads this correctly. Somebody always tells me like 78 people are attending Rosemont. They sort of go this way for some reason. How many people are attending Rosemont? 124? Out of how many total people? 165. What's the only problem in this set of problems where the bottom will not at least start off as 165? 15. This one, right? My 2 C's, I love that. I think I added 1 C in later. But part D is the only one that I'm given information. It's the only one I can throw some people out. All the other ones, I don't know a clue. I don't have a clue who it could be. So how many people could it be? All the 165. So what about, is a business major? How many?
78.
Good, 78 are business majors out of 165. And you can make these into percentages or whatever else, decimals, whatever you want to do. Reduce them, yay. But I at least need to see this initial ratio. Okay. Don't just put a percentage there, because if you make a mistake, I can't see what you did. I can't give you any partial credit. What about, here's our first slightly more difficult one. They're math major or or they go. I was waiting for somebody to do it. So, how many people is that? I saw a few people kind of doing this not quite right. How many people you got to be careful about? Where's the group of people that you have to be careful about? The 7 people. What's special about those 7 people?
They're already counted.
Yeah.
They do both. So if I add up all the people, goes 124 plus the 10 math people, I've made a mistake. I've counted that group of 7 twice. So one way you can take care of that is you could say, okay, 124 plus 10 minus the 7 I counted twice. Or you could be smart and say, okay, 124 Rosemont students, how many math students have I not counted yet? So then that's 127 total, right? You just be smart and not count the 7 twice in the first place. Again, the more work you show me, if you make a little silly mistake and I don't see what it was, I can't give partial credit. So show me this, and then you get 127 and 165, and then you can make that a decimal or percentage. How are we doing so far? Okay. Now here's the one that really trips people up. And I don't blame you, because you've been using formulas your entire time in mathematics. There's a formula for this damn thing. Why would I not use it? Because there's a better way. Formulas work in any situation, and actually would work here. But there's a much easier way to answer this question. I know it's going to be over what? The answer is going to be over 165. And the number I'm going to put on the top is how many people match this description. And how many people are computer science majors and Cuyamaca students?
15.
Yeah, these 15 are Cuyamaca and computer science. So it's the answer is 15 out of 165. Done. Now just to show you, the formula would say probability of computer science and Cuyamaca. I love how washed out it is. Would equal probably computer science times the probability of Cuyamaca given computer science. Kind of sucks. I have two words that both start with C. Just gotta go over here. Everybody with me so far? That is the formula for and. And is probably 1 times the probability of the other dude given the first two. That's the formula. So the probability of computer science is 77. 77 computer science out of 165. Probability of Cuyamaca given computer science. So what goes in the bottom for that? Careful. Given computer science. 77. Out of those 77 computer science people, how many go to Cuyamaca?
15.
Careful. Out of those computer science, 15 go to Cuyamaca, right? So that's 15. And what happens to the 77s? So you still end up with 15 over 165, right? That's the hard way. But if I have a situation where I can just count what I need, I'm going to do it that way. I'm not going to use the formula. Okay, maybe. So again, this is the most honest math course there is. It says there are formulas that work for everything. But dear God, if you have a much easier situation where you can actually just count, please do it that way. Look at that crap. I don't want to do that. No, I want to do that. And finally, you got the given problem. So is a business major given Cuyamaca? So what goes on the bottom? Good. Cuyamaca students, there's 41 in the sample. Out of those 41, how many are business majors? 23. So 23 out of 41. Real quick, somebody help me out. What's part B as a decimal? What's 78 divided by 165?
0.473.
Point 473. What's part D? What's this? The one we just did. 23 out of 41. What's that as a
0.56.
0.56. Now, if I asked you, being a business major and being a Cuyamaca student, are they independent? Somehow I must go off of what I just did. What would your answer be? You got a 50-50 shot. Yes. Are they independent? And unfortunately, you fell on the wrong side for it. They are not independent. Why? What's probably the business major period? 47.3%. So 47.3% chance you'd pick a business major out of this group of people. If I told you, oh, the person I picked goes to Cuyamaca, the probability they're a business major changed. With me? Let me give you this example. If there was somebody who's like 60 and they want to know what's probably going to live a long time, you're going to be like, I don't know, 30% chance you're going to live to what? But if I told you, oh yeah, that person has smoked their whole life, what's probably going to live a lot longer? What happens? It decreases. Now, does that mean they're going to die very soon? No, they can live to be 100 like George Burns almost did, right? They can make it. You guys kind of with me? So what people tend to not realize is just because two things are dependent doesn't mean that one totally determines the other. It just changes the probability. So if I saw somebody walking up and I said, wow, is that a man or a woman? I can't tell. They're too far away. Too far away, not, or, you know. Sometimes you just can't tell. But, sorry. But they're coming up and they're walking towards me and I'm like, I can't tell if it's a man or woman, but I know they just got off of a Harley Davidson motorcycle. The probability that they're a man was 50%, but now would it go up or down? Oh, now right there, I remember one time I had a girl get really angry at me and she said, girls ride Harley Davidson. I said, I never said they didn't. This is all probability. So there's still a chance that it's a woman, but the chances that it's a man went up because there's a lot more men who ride Harley Davidsons. So this is the idea. Does my knowledge of something affect the probability that it's something else also? That's the conditional probabilities. So that's what we use them all the time. You hear this kind of thing all the time in the news, believe it or not. It says if you go to college, you'll make more money. That's the way it's normally stated. How should they state that? That's not true. If you go to college, will you definitely make more money? Hell no. Yeah, there's a couple of things you got to do first. There's just give you a pot of money. Here's your diploma, here's your money. I thought they did, and then I'm like, where's my money? How should they say that?
The probability you'll make more money?
I love it. And actually, we'll even make it a little bit more general population friendly and say the chances that you'll make more money increase if you get a higher degree, right? From a high school diploma to a associate's to a bachelor's to a master's. Every time you go up, the chances you make more money increases. People hear that as, I will make more money. No, the chances you will make more money increase. The chances you will live longer will increase if you exercise regularly and so forth. Any one of us could get hit by something, right? But the chances you'll live longer increases. Kind of with me? Okay. Maybe. All right. So what about number 2? The first couple should be nice and quick. How many total people are in this room? 77. Good. That's the first thing you got to know, so you know what all the denominators are going to be, right? So here, what's probably is a Democrat? 32 Democrats out of 77 people. I like it. What's the probability that they're Republican? 38 Republicans out of 77 people. Cool. Now we select 2 people with replacement. So the first person I select, I put them back in. I'm like, let me take you. No, you look a little shifty. Right? So I put them back in the room. What's the probability we get an independent? And let me show you the way I might represent this question. I might say that probably I get an independent and then a Republican. Right? IR would be independent and then Republican. Are you with me? I might use those symbols. So what's the chances for the independent?
7.
Yeah, there's 7 independents out of 77 people. And then I put that person back in. What's probably the next one's a Republican?
38.
38 out of 77. And then whatever that whole big mess is.
48 out of 47.
What's it going to have to be? 0.15? 4.5%? Does that jive with everybody? All right, I'll take your word for it. If you show me exactly this on a test or a quiz, kick ass. That's perfect. As long as it's right. Yeah. You can give it to me percentage. You can give it to me as a decimal. You can give it to me as a fraction. I desperately need to see this work. And then you can do whatever you want to with it. You do have to go one more step. Don't just stop there. Right? I need to make sure you can actually do this in your calculator and give me something. You gotta get that one answer. Everybody cool so far? Good, good. What about 2 Democrats? So the first one is a Democrat. I put them back in, so the second one is still 32 out of 77. 17.3%. Does that sound good? A trusting fool. All right, good. I'm going off for that. All right. Crowdsourcing the answer. So what about now? I think you're going to pick up on this. I like to do this where I ask you a set of questions and I ask the same exact questions in a different situation. So now we're without replacement. What happens with the independent and the Republican? Independent would be 7 out of 77. And then a Republican becomes 38 out of 76. Good. There's still all 38 Republicans, but there's only 76 people now. Because I took somebody out of the room and they're like, thanks for getting me out. And then whatever the hell all that stuff comes out.
1 over 22.
1 over 22.
1 over 22, neither. Which is about 4.5%.
So,
you'll notice on a test or a quiz, I might actually ask you to go out to 2 places on a percentage, so that you'll actually see there is a slight difference between here, but it's very tiny. So if you went out 1 more decimal place, they probably won't be the same. But if you're around the first decimal place, it looks like they're the same. Are you guys kind of looking? Obviously, they can't be the same because we changed the freaking number in there. But it just doesn't show up in the first decimal place in this case. 2 Democrats. The first dude's a Democrat.
32 out of 77.
And the second one's a Democrat.
31 out of 76.
Good. Now they both have to change because there's 1 less person, 1 less Democrat. I like it. And then whatever all that comes out to be. Was it? 17%? So just a little bit less than what it was if I did it with replacement. I like it. Okay. How's that? Those are the exact kind of problems you'll see from me on the quiz. So let me see. All right, so one last quick idea, and then we're done with chapter 4. Pretty good time, okay, good. Oh, let's see, that's where I'm going. Take my... So, go with me here for a second. Do this horrible thing to you again. Probably as a king would be 452 out. Normal deck of cards. All right, we know all that so well. If I pick that king and then throw it away, so what's probably as a king given? I already picked a king.
351.
All right, now somebody help me out. Change those into decimals. Go out 4 decimal places. What's each of those decimals? First one is 0.0769. Okay, I don't hear any disagreement. The second one, 0588. Now, obviously, you agree with me that those are big changes. If I lose 1 king, right? If you're playing poker and you got 2 kings, and you're like hoping for another king, and you see somebody else already has a king, you're like, shit. Because the probability to get 1 more king has just gone way down. Got it with me? A little bit? All right, yes?
So that one is with replacement, the second one?
Well, this is without replacement. So this is, given that I already picked a king and it's on the table, then the other one still is going to be a king. It's gone down. It's gone down by a decent amount.
Oh, without.
You guys with me? Okay. So, what if I said, I've got 10,000 cards, and I pick, let's see, how do I say this? Let's say 400 of them are kings. All right. If I pick 1 card, what's probably as a king? 400 out of 10,000, which of course is 0.04. You guys with me so far? Nothing amazing there? What's probably now, and I throw that one away, right? So it's probably now that I pick another king, given that I just picked a king, what's that probability become?
399 over
399 over
9,999.
Okay.
9,999.
And do that for me. And this is actually out as, it's actually exactly 0.04. How does that one come out to 4 decimal places?
Very close to 0.0399.
What do you get? Say again?
0.0399.
0.0399.
99. 0.
Okay. Now, is that a very big difference?
No.
Compared to how big a difference that is? I mean, now I know a lot of you guys would say that's not a big difference. But it really is. That's 6% if I round up versus 8%. That's a decent difference. If the unemployment rate went from 8% to 6%, hello, that would be a huge talking point for people that would like it to happen. Right? Here, if it goes from 0.04 to 0.0399, I don't think anybody's going to be out there, the American public's going to be like, okay. That's barely worthy of anything. Are you guys kind of with me? So, and it's basically because I have such a large population. Here, do I have a large population? No. So, here's the beautiful thing that we can do. If our sample size, like if I was taking, here I just took 2 cards. 2 out of 10,000 is not much. You with me? So it doesn't really matter if I call it with replacement or without replacement. The probabilities don't really change that much. Whereas if I have a smaller population, taking a few cards is actually relatively a big amount to how much population I've got. So here's the idea. This is the 5% guideline. If your sample size, the sample, is less than 5% of the population, you can treat all the probabilities as independent. You don't have to do all this weird, look at that, that was kind of painful. You can imagine if it was 100,000, so, you have all these freaking 9s floating around, and good God, I don't want to do that. If your sample is less than 5% of the population size, you can treat everything as independent. So what do I mean by that? I mean this. Example. 11% of the American public is left-handed. Last time I checked, it was still 11%. If I pick 4 people, what's the probability that all 4 of them are left-handed? Careful, careful, careful. So I want the first person to be left-handed. Continue my sentence. I want the first person to be left-handed, and the second person to be left-handed, and the third, and the fourth. And you start to see in my brain, I always think like the hangman game. I got 4 people I'm picking. If I can figure out the probability for each of them, I can just multiply. Now, normally we would write. Now, can you imagine? What would now what I always get is somebody does this: 11 out of 100 times 10 out of 99. What is very, very wrong there? No. I just took them aside. Now you can do what you want to with them. You're like, I don't trust left-handers. That's over there. What are you? I'm right-handed.
That's not the actual population.
Yeah, you're saying there's 100 Americans. What the hell? There's 100 people in America. I'm like, what just happened? There's only a small part of San Diego left. Right? The rest is a wasteland. All right, that's crazy. But they say 11% is 11 out of 100. I don't care. It's 11% of what?
Population of
320 million, whatever the hell we are now.
US.
You with me? So the bottom on these would be 320 freaking million. Can you imagine? You would do 11% of that over 320 million times 1 less over 320 million minus 1. Can we all collectively say, screw that? So how big is my sample? How many people am I picking? That's the sample size, right? How big is my sample? I'm picking how many people?
4.
4 people, thank you. So my sample size is 4 out of
Whatever
the population of America, which is roughly 320 million. Do you think that's less than 5%?
Yeah.
Hell yeah! So I am completely allowed. Now watch this. What's probably the first person is left-handed? 11% chance. Screw setting up the ratio. The first person is 11%, 0.11. What's probably the second person is left-handed? 0.11, 0.11, 0.11, and the shortcut would be 0.11 to the fourth power. Kick ass. So technically, we're wrong if we do this. But we're wrong probably in the 18th decimal place. So normal humans, we wouldn't care. And if we do care that much, well then get a computer to do it for you. Right? But I mean, the difference, I don't even want to write what it would look like if you had to do it like this. I'm hoping you guys can kind of imagine that. The tops would be 11% of 320 million, and the bottoms would be 320 million, and then 319,999,999. No. Right? Yes.
So that's without replacement.
I want you to be careful. This is completely without replacement, but I can treat them as if they're independent because my sample's so small. The probabilities, how much are they going to change? Barely anything at all. Less than this changed. And that's not a change at all, basically, right? You guys kind of with me here? If my population is very large compared to my sample, if you want to be more technical, if my sample is less than 5% of my population, I am completely allowed to do it this way. I couldn't do that with cards, right? If I pick like 4 cards out of a deck of cards, 4 out of 52 is like 8%. It's way bigger than 5%, yeah.
Like, let's say, would I always get a percentage? Like, if you solve this problem, you know, you get the 11% right there. What if you didn't have that?
I'd have to give you, you'll see problems in the book that say out of 8,000 parts on an assembly line, 20 of them are defective. So you do 20 divided by 8,000, that's your percentage. And then you can just use that. So 4 are defective would be that percentage times that percentage times that percent. Are you with me?
I was just thinking because of the American public, we don't get an actual number. You know what I mean?
Yeah, but I could do the same problem. I could say that 320 million people in America. Blank million of them are, 32 million of them roughly are left-handed. So you have to set up the ratio and get this percentage. And then you can just plop, go to town. You don't have to do the ratio and then one less and then one less.
Right.
Holy crap, right? So what is 0.11 to the 4th power, by the way?
0.014641%.
Point?
0.014641%.
It should be less than that, I think.
Point
Oh, 0.01%, you mean? Did you make it into a percentage?
Yeah.
So as a decimal, what is it?
1.4641 times 10 to the negative 4.
Okay, so then 0.00146, like that? Yeah, so that negative 4 just means 4 places back? Cool?
Yeah.
Okay. All right. Oh, some of you guys are like, I really still don't like statistics, but I love the look. Some of your faces. I'm so happy I don't take it personally. But I can do something now like if I know that 68% of people wash their hands after using the restroom. Okay, that's gross, but it's true, and that's why you always open the door like that. And I pick 10 people. What's the probability that they all wash their hands? Let me tell you. Probability that all wash their hands. How could you do that very quickly now? Because we're talking about people, all people, not San Diego people, not even maybe in America, maybe all over the world. So let's just say people all over the world and in the known universe. Exactly, right? I'm going to have 0.68 10 times. The first one washes the hands, and then the second one washes the hands. But the way to make that quicker is we use algebra
To the 10th
to the 10th power. So what is 0.68 to the 10th power? 0.0211? So if I pick 10 people at random, and this is a true statistic, and it's not really, but it's somewhere around there. If I pick 10 people at random, the probability that they all wash their hands is only 2% chance. So let me see if you guys can get this. What's the probability that at least one did not wash their hands? What did I say about at least one? Do you guys remember? What's the opposite of at least one? It's none. So the probably at least one did not wash their hands is 1 minus probably that nobody washed their hands. Oops. Or they're probably that none didn't. They're probably that none didn't. So another way to say that, a little better way, a little more grammatically way to say that, that all did, right? That none did not. So English would probably come in and say, Jeff, okay. So that's 1 minus the opposite of that. At least one not washing their hands. The opposite is none did not wash their hands. And that's a little better to say they all did. And what's really cool about this question, in this example, we already did it. So this would be 1 minus 0.0211, which is 0.9789. So if you randomly select 10 people, what's the probability that at least one of them did not wash their hands after the last time I went to the restroom? 98% chance. Then you start to understand why people are germophobic. I'm actually not. And anytime I do that kind of problem, I'm like, maybe I should be. Sure. You guys kind of with me? This is exactly the kind of problem I love to give. And I always like to do questions here that depend on work that you already did. It's kind of me trying to be nice. And people always don't use the work they already did. So let me give you this so you can at least look at it before you head out. This is that practice quiz on probability. No. Yeah, we just went over all of it, so no point to it. So number one is the problem that's exactly like this problem, right? I know it's from 2009, and I don't care. Because this practice quiz is the same practice quiz I've used since then, because I've got the answer key already made. The actual quiz you're going to take is going to be either based on data I collected from you guys, or data I actually get off of some official, the Census Bureau or something. Real data. Okay. Yes?
This one's like with looks like it's with replacement or 11%.
So again, what is it about, even if I did something without replacement, like this problem here. I want to pick 4 people, and I'm going to pick somebody, and then pick somebody else, so I'm not putting them back in. I'm taking somebody out of the U.S., right? A little UFO comes up. So technically, all the probabilities should do what? They should change. But this goes from 0.11 to 0.1099999999999999999999999999999999999999999999999999999999999999999999999999999999999. Who cares? It's basically freaking 0.11. So the whole point of this is if my sample is so small compared to my population, you can treat them as if it's with replacement, as if it's independent. You can treat them, it stays the same throughout the whole problem, which makes it possible for me to do this. Just collect it together. 10 of these. Because 10 compared to the population of the world, which is what, 7 billion now or something?
Yeah.
That's nothing. So I'm allowed to treat them all as if they are independent.
Treat them all as independent.
As independent. And with replacement is one example of an independent setup. All right, guys. That's plenty. Who did?
But he.
Oh, Heinrich. Okay. All right.